Hello and welcome to Factor by Grouping. This is a method I'm going to teach you that needs 4 terms. If there are 4 terms, then we can do what's called factor by grouping, where you group the first 2 together and you group the second 2 together. I'll show you. Let's say we've got something like this with 4 terms. What I can do is I can take these first 2 and group those together, and the second 2 and group those together. And I'm going to find the greatest common factor out of the first 2 terms. The biggest thing that can be divided out of both of these is x, and that leaves left over x plus 3. The biggest thing that can be divided out of these 2 is 2, and that leaves left over x plus 3. So now, I've got 2 terms now. I've got a red term, I've got a green term. They're being connected by addition. These 2 terms have a greatest common factor. The greatest common factor, the thing that I can divide out of both of these terms, is x plus 3. There's an x plus 3 sitting there that's being multiplied in both terms that I'm ready to divide out. So if I divide out x plus 3 and I put that in the front, and this is gone and this is gone, then what's left over from the first one is x, and from the second one is 2. And now it's factored. 2 things multiplied together, that's what I want. Done. Okay? Example 2, group these 2 together, find the greatest common factor, that is 2x squared, and what is left over is 3x plus 5. And now in the second 2, I look for the greatest common factor, and it is nothing. When there's nothing, I can always pull out a 1, because this is still factors 3 and 1 and 5 and 1. So I can still pull a 1 out, and I need to do that in these problems. I need to put a 1 there so that this method works. Now I've got a red term and a green term, and they have a greatest common factor of 3x plus 5. So I pull out the 3x plus 5 and I put that in the front. And then what is left over for me is 2x squared plus 1. That's parentheses. Here's my leftover. Here's my leftover. The 3x plus 5 is in the front. Okay, pause the video now. I've given you some steps you can copy down. Pause the video and then try example 3. Go. Pause. Okay. And start. Here we go. Let me work through example 3 for you. We're going to group these first 2 together and look for the greatest common factor, which it looks like is 4n squared. And that leaves left over 5n plus 3. And then in the second 2 terms, the greatest common factor is 5. So we've got 5n plus 3. Hey, I see a GCF here. We've got a 5n plus 3, 5n plus 3. If I pull that out in the front, 5n plus 3, that leaves 4n squared plus 5. Did you get it right? I hope so. Goody. If you got it right, go on and do the next one. Pause it and try. And here we go. These 2 greatest common factors, 3x. And left over is 5y plus 2x. Out of these 2, the greatest common factor, they both have an n. So I'll just pull out an n, and that leaves 5y plus 2x. And hey, looky here, 5y plus 2x, 5y plus 2x. Pull that out in front, 5y plus 2x. And 3x plus n. If you got that one right, you are good to go. There's just one little problem. There's a wrinkle with these problems sometimes that I need to show you that we need to be careful about. Be careful if the signs are not the same. These are bigger for you. Okay? And here's what I mean. I'll show you. Problems like this. Make these a little bigger for you. Sometimes the signs are not the same, and you might need to divide out a -1 to make the signs match. Here's what I mean. Greatest common factor is 4v That leaves me 7v squared plus 4. Oh, no, 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 no. No, 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 no. That's not 4v. That is 4v squared, 7v plus 4. And then here, if I pull out the greatest common factor here, that looks like 3. And that leaves me negative 7v minus 4. Okay, so now I've got my 7v plus 4 and my negative 7v minus 4. Those are not the same. Aha, I don't have a greatest common factor. They are not the same. So when this happens, what I need to do is think, if I divide out a negative 1 here, that would change these to both be positive, and that would match with these that are both positive. So that is what I will do. I'm going to divide out a negative 1 here. And so instead of positive 3 in the front, I'm going to make it negative 3 in the front. And now that divides to make 7v, and that divides to make 4. And oh goody, now I have my 7v plus 4, 7v plus 4. And so I can pull out the 7v plus 4, and that leaves left over 4v squared minus 3. So be careful if the signs don't match. You can't just carry on and pretend that they're the same if they're not the same. We need to divide out a negative 1 to make it work. Okay? I'll show you another one. This GCF is 4x squared, so that leaves left over x minus 3. Right? This GCF here is 5. That leaves left over negative x plus 3. Oh, not the same signs. But if I divide out a negative 1 and I make it negative 5, then this changes to be positive, this changes to be negative, and now I have a match. So sometimes we just need to do that little extra step so that we have a match. We have my x minus 3s are the same. So x minus 3 comes in the front, my leftovers go after. Okay, looks like I'm getting a text message. Maybe somebody loves me. Okay, you try this one. Go ahead and pause and try. And here I go to finish it off. This is the last problem of the day. We've got our greatest common factor here. I'm going to say 8. And I'm going to say r squared. And that leaves 3r minus 8. And then here, let's see, 7 I think. All right, plus 7, and that leaves negative 3r plus 8. And that gives me my greatest, oh, it doesn't match. That's okay, Bibza taught me how to change it. I'll just change this and change this. And then we got this still the same. And looky, looky, here we go. Now it's the same, 3r minus 8. And leftovers are 8r squared minus 7. All right, and we are done. Have a fantastic day factoring.